Welcome back, everybody. It is my great pleasure to introduce one of our alums who has returned, air quotes, home to give a talk. We have a lot of alums that we are very, very proud of, many of them here in the room right now. But Kevin has not only gone out and done unbelievable things within the industry, but continues to make sure that he is engaged with Cerias, even though it's been a number of years since you got your PhD here. So, and has done some very novel and very cutting edge things for cybersecurity education that again, he has developed, but continues to share with us that we have used for resources with our students. So with that, it's my great pleasure to introduce the Meredith Professor of Electrical Engineering and Computer Science from Syracuse University, Kevin Du. Kevin, welcome.
Thank you very much. Yeah, so it's very glad to come back. And yeah, so what I'm going to talk about is I'm going to talk about my education project. And research and education is in the name of Cerias, and I take that very seriously. So when I actually become a professor, I actually while pursuing the research career, and I spend a lot of time and working on the education side. And so this is one of the things that I've been working on since I actually started my career in Syracuse. And so when I like to teach students hands-on things, and not just the theory. I like to give them hands-on exercises. But at that time, and when I get started, I look at the internet trying to find material that I could use. I couldn't find many. So I come from Purdue, I'm Boilermaker, right? I just built it. So, so that's what I basically did. And I started building and just growing. And eventually right now we have more than 1,000 institutes are using that. And that not only just including the university college, but also some high schools. And also I know some of agency, FBI use that for internal training, and some of the West Point and Navy and the Air Force Academy, and they all use that. So basically a lot of people are using that. And because they need, many of them need an instructor manual. And so they actually have to contact me. The instructor manual is not online. Everything else is online, free. And so when they ask me for instructor manual, and I know who is using that. And if you are using that without the manual, and you can definitely do that. And also since 2015, and actually I started training the professor to use that. So we actually are I had the NSF grant. So we actually every year we bring about 80 professors coming to the campus, and we have spent 4 days, 8 to 5, basically a very intensive boot camp type of training. And so during the pandemic, and I moved that to online, and now that actually now opens up to the entire world. So I have a 400 in person and about 400 and from online, and total 800. So that was a very good actually the period. I was actually based Saudi Arabia actually also sponsored us and to go to Saudi Arabia and to provide a one-week training to their professors. And so we had some of the international training workshop. I also, based on my hands-on lab, I actually wrote a textbook, and not just one, but now 2, because there are 2 volumes. And within 5 years, I got 255 universities adopting that as textbook. Most of them, of course, they use my lab first, and they start to switch to my textbook. And it's very hard to convince people to switch textbook, but if they are using the lab, and it becomes easier. And on the side, I'm trying to make some money to buy my beers. So I actually record lectures, and I actually build my own recording studio in my basement, DIY style. And I actually recording them, I adding them, and put on Udemy for sale, $10 each course. And I made a reasonable enough for me to buy beers. So those are some of the education things I've been doing. But there's always one thing I could not do for many, many years, and that is I teach BGP in my internet security, and I want students to really be able to launch the BGP attacks. So BGP attack is on the internet scale. It's not that you can do with a few computers. You need the internet, and obviously you need access of real BGP router to do that. I don't even have access, and I teach BGP theory. I don't have much experience on the real BGP. There are many people knows how the BGP really work in practice. I just could not hire them. They work in Cisco, Google. So I want to build a emulated internet just to solve that problems. But for many years I couldn't because the skill that I don't have the hands-on practice skill on the BGP until one day actually I had a student, undergrad student in my class. He somehow in high school, he owns a real BGP routers. And that costs $6,000 per year, and not for business, just for hobby. And that student shows up in my classroom. And that we end up actually now working together and to build this internet emulator. And so initially it was for just solving that problem for education. But as soon as we finished that, we said, oh, we could do many, many more things. It's a platform. I will show you some of the fun things we did. And also, once we released that, this is an open source project. Once we released that and we found some research, they are also using that. So I said, that's great. So maybe we can think about what are the research future we can build into that. So basically started from one thing, and now we're actually doing a lot of things. So I'm going to do the demo first. And so otherwise presentation is boring. And this is the number one thing you should not do in a presentation is to do a live demo. So, but I'm going to do it anyway. So, so here we already have my emulated internet. So what I want to do is I want to run an internet, a mini-sized internet inside my this 4-year-old laptop, not very fancy one, just very old one. And this is, you can see, this is even running inside the virtual machine, not even running on my host machine. I only have how many? I only give 8 GB of RAM to this VM and core. That's very, very low end the machine. And I am running a mini-sized internet here. Now these are not just pretty picture, and these are actually really, each of them is a computer, but of course a lightweighted container. Okay, so if you understand what a container is, and those are very lighted and weighted computer, I have 80 of them running inside my very simple VM. Okay, you can run easily 100 without any problem because of a container technology. Okay, so inside here you can see this basically is a network, and we really use it to emulate our organization, our autonomous system. And then this star, let me just pull one which is closer to us, Chicago, here. So this star actually it will emulate our internet exchange. And that's where the BGP routers, if you see those around one, those are the BGP routers. And they will peer at internet exchange, and they will exchange the traffic. And those nodes runs the real BGP router software, not a fake one, not simulated one. They are running the real one, of course, the open source one we use, and the one that is being used in the real world. Okay, so each of them is really a computer. You can access them. So let's see, I'm trying to access this one. So here you can access, and you will get into a terminal. This font is too small, but it just basically, I'm having a shell prompt inside here, and I just run any command you want, and I'm just running here. And I'm running the pin, and when you run the pin, and the packet will goes, and that how the packet goes is decided by the routers, by the BGP routers. If you change some of BGP peering, and you're going to see actually routing path going to change. Okay, so when I do the demo of attack, you're going to see we're going to use launch attack to change the flow. Okay, so these are just full visualization, but this picture is the least significant part of the project. And when I present, I have to present this part, but many people think, oh, this is the most important. No, this is not. The one that behind this is the most important one. This just make it more appealing. Okay, in terms of the amount of effort you put on, and this is the least important part. And this one, that's one. If you want to see how the packet really flows, and you can do the record and replay, and then you will see exactly, because that one goes very fast. So this one you show how the packet really goes. And those are real packet, not just a visualization. Those are the real packet flow. We have installed the TCP dump on every node. and they will just report, I have seen this packet, and now it visualizes in here. Okay, so I'm just going to stop this pin. Okay, going back to my this. So before we do this, we actually look at a bunch of the solution, the emulation, trying to see whether we can do it with the existing technology, and we couldn't find anything, and that's why we actually started building that. And our idea is actually very simple. So because we already know the Docker, so we said in terms of emulation, there are two parts of emulation. One is to run emulation. The other one is to build emulation. The one that runs emulation, you can just use a Docker technology. Those are very, very mature. So our job end up just focus on how do we let the user to construct an internet based on their need. How many BGP router you want, how many network you want, how many autonomous system you want, and then provide API for you. We build a Python class for every single essential element of the internet. We build classes, and then we implement API for you to customize them. So using those classes and using this the API, and now you can easily, for example, create a transit autonomous system, which is connect multiple cities. Those stars, they are the internet exchange. So this one you can internally, they are very simple. I'm using a very simple example, but in the real world you can make it complicated, and by creating a network, creating a router to connect the network. And so you can build any topology you want. And then the configuration will be automatically done by those, if you are connected to the internet exchange, and those will be configured as BGP routers. And then how that is configured depends on your peering relationship. If you say, I want to peer A with B, and for you, you don't need to understand the BGP much, because that actually took me a few years to wait for that student. Because that's the core part. I don't understand how to do the BGP configuration and in the real world. I know the theory, but we're talking about the practice. For doing this, you just need one line. You just need to say, I want to peer this with this at here, and that's it. And all the dirty work is done then behind the scene. Okay, so that's why you don't see this all the code part, but those are part of our open source, the project, and you can use them. And so that's just the how we build it. I only show you a very small example, and we have a lot of examples you can look at from our GitHub. So I want to show you this. We're not just building that emulator. We actually consider a lot of interesting scenario. For example, when we actually release that, and one of the team says, I want to connect my IoT device to your internet emulator, so I can actually run some of my program on the internet to interact with IoT. I cannot modify IoT, but I can modify something here. And so we actually come up with a very nice solution. We just stick out basically USB to Ethernet card, connect to the Wi-Fi, then your IoT will connect to that. So by doing that, your IoT is now participating in the emulation. I actually brought this setting to my classroom, and I told the student to disconnect their smartphone and the laptop from the university Wi-Fi, connect to my Wi-Fi. By doing that, their traffic gets routed into my emulator. I become their internet service provider. And I also poke a hole from, you can see on that side, I poke a hole from my emulator. So the traffic can actually go out. So if I want them to go out to Purdue, I poke a hole and to get out of Purdue, or poke a hole to get out of Syracuse. Then I said, okay, I'm going to launch attack against not Purdue, Syracuse. So of course, I'm on launch attack all within my internet, not the real one. But as soon as I do that, the student immediately lost connection to the Syracuse website, because their traffic will go through my internet first, and my attack is launched in this internet, we call the shadow internet, and then get redirected. All their packets get redirected to a black hole, and they won't be able to access Syracuse, but they are still able to access Purdue, because my actually hijacking only hijacked the Syracuse University network. That is really how the BGP attack really works. And I will demonstrate that when I think I have a few minutes to do that. So we also look at scalability issue. So for this one, I can emulate 100 nodes. What if I want to emulate 200, 300? And we have to find a nice solution. And to do that, and actually have I won't have the time to demonstrate that, but right now I have 3 machines set up on the cloud. And these three machines, they emulate each segment of the internet, and we have to find a nice way to merge them. So if I send the traffic from this one, and they will go out to there if the destination is there. Okay, so we actually have this cloud-based, and so you can scale that up. That is just base layer, and we said with the internet, if you only have this base layer, it's not that interesting. I want to build interesting software, put the interesting software on top of that. Remember, each node is a container. You can install any software you want on the container. Some of the software need a much more complicated configuration. So you can install web server, those are easy. And we actually did spend a lot of time on the blockchain. So I can deploy a private blockchain on top of this. Actually, on my internet, I'm already running that. So here I'm already running that. You won't see that, but if we have another, not visualization, but kind of user scan, look at all the transactions that are happening and in the background. So we have the Ethereum, the running on top of that. So I have 20 nodes. Okay, so that is actually the service. We spend a lot of time building. We can have a darknet. If you want to deploy a darknet here, and we already have a module for you, and you can just need to maybe 20 lines of code. You can add a darknet, botnet. We have that. So if you want to teach that or do some experiment with that, we have we can deploy those things in here, and we are keeping adding new modules. And because all of them are just the real world open source software, all we need to do is to really to actually customize them and to help the user deploy them on the base layer. And we have to design that just using the chip and the motherboard design pattern. So all of these things could be actually plugged into a different emulator. You're not hard-coded into one emulator. They could be actually moved to a different place. And for the Ethereum blockchain, and you can actually use any existing software to communicate with that. So here, for my demonstration, I can just show you, I am really actually I removed that. So yes, okay. So somehow I closed that. So I was planning to show you the MetaMask connecting to. I'm going to show you how rich I am, because when we customize the blockchain, you can customize how much Ethereum you have. I have, I don't know how much, but convert to US dollar is 10 to the 25 US dollars. So you can customize how rich you are. So because you own everything, you build everything. We have API for you to customize your wealth. Okay, so that's pretty much just for these two demonstration, and for this one, and I called them yesterday once more. And from the name, and this comes from Carpenter's song. But what I really want is I want to bring back all this the existing, the well-known and the attacks, and I want to really turn them into labs or demonstration. For this BGP, really just model after 2008 Pakistan hijacking the YouTube by mistake, not intentionally. And that was actually this one. I will show you that. And then this Morris worm and the 88. And so I have a lab, so students need to write a worm, and their job to release the worm from one of the nodes from my internet. That worm has to crawl by itself. And you are only allowed to attack one node, but then that crawl eventually conquer the entire internet. And so really a simplified version of the worm. And we provide a lot of guidance so students understand how the worm really works. When I started to do this, I know the staff wrote an analysis paper back to the ADA. So I have to dig out that paper and read it for 20 more times to fully understand how that really works. And I thought I understand that, but once you start doing that, you find out theory and practice is just huge gap. Doing that, and you can do that. So here I'm going to quickly show this one, the demonstration is very simple here. So here I am doing this one. And imagine on the left side, on that side, that is YouTube, and I'm just a user and visiting the YouTube website. Okay, so now I have an attacker here and on here. So basically owns our autonomous system. And in this case, we're emulating the mistake made by the Pakistan government. And so they actually configure their BGP router, but incorrectly, that end up actually hijacked YouTube's network. Okay, and this is the exact same techniques used by the attacker. So whether it's mistake or attacking, and technically they are the same. So to do that, what I do is the student's job really is just to configure that BGP router, and so you announce that you own YouTube. Okay, so basically announce YouTube the prefix and add one more bit. So that is the only thing you need to do, and I have everything already written in script. So as long as I hit the attack, that attack will actually update the BGP configuration inside that container, restart the BGP router, and then you will see the traffic and redirect it. Immediately, actually, the traffic redirected, and you will see from here, from this one, and you will see my ping is not going to actually do anything because I don't get anything back. So your ping goes to a black hole. And so when this happens, YouTube actually detected this happened. So their engineer immediately trying to contact the ISP and of the Pakistan, basically upstream, but they could not reach them. So they actually did an anti-attack using the exact same techniques, try to steal back their own network. And the first time they did it wrong, did not work. But then a few minutes later, and they did it correctly. So, and I am going to fight back here, but basically just reconfigure your BGP router and to announce one more bit longer. And so you take it back. And so, and this you can see, my traffic will come back. So this, of course, you're not supposed to do that. But you cannot get problem resolved legally. That's a temporary solution. And this was all documented. And that's I read the story, I look at what's going on, and so basically I said, oh, we could recreate that. And so now when I teach BGP, I don't need to tell the story. I let students work on this themselves, so they fully understand the attack. So this actually is the then for the one more minute, I will just show you here because I think this this worm is really a very interesting one to look at. I'm not going to do live because it's going to speed up my VM, and so I'm going to show you just the video. Okay, somehow my video is not. Okay, yeah. So just 1 minute video, and I speed up the. So this is also on YouTube. You can see the link. And so here, this is the internet emulation. I have 220 computers in my internet. So each of these cluster is really autonomous system. I have installed a vulnerable version of the server on each of them. The student's job is to write a worm, break into one of the computer, and that worm call itself, because that is your part. And what you see here is really just one terminal, one of the computer, what is happening on that computer. And you see the smiley face, that means the code is already actually attacked successfully, and now it's looking for its next target and find a live one, and then doing this. And when they actually concur that, and that node will flash, because as soon as we concur that, we just pin 1, 2, 3, 4, then that will capture this will capture all the screen, all the actually the packet, and you will see they're flashing very fast. I speed up 5 times, but this will eventually, and you will see the CPU usage reach 100%, because I intend to preserve the bug in the Morse code. It did not actually detect whether this itself is already infected. And so by self-infected again in the exponential mode, and you're going to actually basically exhaust all the resources. So that's actually what I want to talk about. And let me just jump to the last slide. Yeah. So this is the open source. I already built the lab, and so if you just want to use them, feel free to use them, or you want to play with that, or if you want to contribute to this project, we have a lot of interesting idea. You can also contribute your idea, and so that's something that we've been working on.